a very nice graph. It gives us a graph, excuse me, like this one. Now, excuse me, along the bottom of the screen, these are the types of incidents. So this is the data that we were looking at. This is the 250,000 records. This is the data we're looking at, and so these incidents are now mapped along the bottom of this graph. And these indicate how similar these incidents are. These incidents are now ranked by similarity. So all the incidents in this particular area are similar. All the incidents in this particular area are similar. It turns out, when you do this, that there are about 15 types of incident that the fire brigade get called out to. So of those 250,000 incident records, there are actually only 15 types of incident that the fire service get called out to. Now that is quite a useful piece of information, because if you're planning on putting equipment on a fire engine, you now know that for the majority of the things that you get called out for, there's only 15 types of incident. Therefore, you only need to stock equipment on a fire engine to deal with those 15 types of incident. If you ensure that your staff, your firefighters, are trained to deal with those 15 types of incident, then they're going to be able to deal with the majority of the call-outs that they receive. Now we want to expand this and look at the kind of entire data set, because if you do this, it changes the way that the service operates. It turns out, if you look at this particular data, that the majority, the largest type of call that the fire service are called out to is a well-intentioned false alarm. So that's where somebody's smelt smoke or something's happened, and with the best of intentions they've phoned the emergency services and the fire brigade have attended, they've turned up on the scene and they've decided that there is nothing that they need to do. So you have a well-intentioned false alarm. Is there any need to send a fire engine, a large vehicle staffed with 6 or 7 firefighters, a whole range of equipment that is actually quite a slow-moving thing? Is there any need to dispatch that vehicle if the majority of the calls are well-intentioned false alarms? Could you change the way you deliver the service? Why not dispatch a fast car? Why not, as daft as it may sound, send a fireman in a Ferrari or a Lamborghini or a sports car? They can get to the incident very, very quickly. We've only dispatched 2 members of staff. There isn't as much kit on the vehicle, so it can get through traffic a lot faster. Why not send a motorbike so that the motorbike can get to the incident really, really quickly? And if there is a need to send out a fire crew, to send out more equipment, that motorcycle rider can request that, and there isn't much of a delay in doing so. So by looking at this data, by sequencing this data, we're able to identify patterns, identify kind of sequences and families and similarities, and based upon that, we can change the way that we provide the service. Now, I appreciate that this is a fire service, and it is in the UK, it will be quite a contentious thing to say, do you know what, we're going to start and send motorbike riders out there. So maybe that's something that won't happen. But if we look at a more commercial application, let's look at a more commercial application. Let me kind of imagine a scenario. Let's imagine a situation. You have a supermarket. And the supermarket places an RFID transmitter, an RFID tag, on every one of its shopping trolleys and every one of its shopping baskets. And around the supermarket, in 3 or 4 places along each of the aisles, they place an RFID receiver. Now all of a sudden, we're in the position of being able to track a customer through our store. So a customer attends the supermarket, takes a shopping trolley, and walks around the store, shopping, picking up goods as they go. And as they drive that trolley, as they carry that basket around the store, the RFID transmitters are picking up as that trolley passes. They can tell whereabouts that trolley is, whereabouts that shopper is within the store, how long they've spent on each particular aisle, how long they've spent on each position within the aisle. If we've got 3 or 4 transmitters down the aisle, we can track where people are within the aisle. Then, having done your shopping, the shopper then goes to the checkout, and the goods are put through the point of sale system, at which point we're able to link the RFID tag that is on the shopping trolley, on the shopping basket. We can then link that to the actual purchases and the items that the person purchased. So now we have a map. We have a map of how that shopper moved through the store, and we have a map of the products that that shopper bought. Now maybe in your particular supermarket you use loyalty cards. Loyalty cards are quite a common thing in the UK, where you would scan your loyalty card and claim points which enable you to get discounts and things like that, but it also enables the supermarkets to tie your purchases to a known identity. So maybe you scan the customer's loyalty card. So now all of a sudden we have a known identity because we've scanned the customer's user card, loyalty card. We have a known identity. We have a purchase. We have items which we put through the point of sale system, and we have a map of whereabouts in the store that shopper went. That data is very, very similar to the data that we've got from the fire service. It's auto-generated data. So we can run that sequence analysis on this kind of mapping data, and if we've got enough of it, if we've got enough shoppers coming through our store, all of a sudden we can start and build up a picture, we can start and build up clusters and identify types of shopper. So maybe we get shoppers, the majority of our shoppers are people who just rush into the store or in an evening after work and grab a few items from the fresh counter and maybe some milk. Maybe a large proportion of our shoppers are female, mothers or wives who are doing a large weekly shop once a week, purchasing a lot of groceries. Maybe we've got younger people coming in who are just purchasing a few groceries and maybe some alcohol. We can identify different types of shopper. And if we can identify different types of shopper, if we can identify different buying patterns, different shopping patterns that these shoppers have, all of a sudden we can start and structure our shop. We can change the layout of products. Maybe the large portion of our customers come into the shop wanting some fresh food and a bit of milk. Well, then we've got 2 decisions. We could either say, actually, I'm going to put the fresh food and the milk at the front of the shop where these people can just run in, grab them, pay for them, and go. Or maybe we're a bit more savvy. Maybe we put the fresh food at the front of the shop and the milk at the back of the shop. So now all of a sudden our shoppers run in and grab the fresh food, but then have to go through the entire store, exposing themselves to all our marketing, all our fresh products, all our brand new products, our offers, our tantalizing items before they get to the milk. So maybe in their passage through our shop, they will be more inclined to buy, to pick up more things. So just by placing these little RFID tags on our shopping trolleys, we can start and track shoppers through our shops. Now, please don't be under any illusion. This is done. This is done in the UK. We don't use our RFID tags in the UK. We use the kind of mobile phones that people carry, and we will put a wireless network in the supermarket and tell shoppers that the wireless network is free. And people will switch on their mobile phones, try to connect the wireless network, and they will connect the wireless network, they can surf the broadband. But because we've put wireless access points throughout the store, we can track people through the store using the MAC address of their mobile phone as a unique identifier. So we're able to get this kind of data, and supermarkets and stores do get this kind of data and will lay out their stores based upon that. So that's an idea of a commercial application for that. So you could arrange your products based upon the shopping patterns of your customers, and you could equip your store, you could train your staff based on the kind of customers that you were coming to your store.